Okay, so we're looking at question 92 from chapter 14. And the question says, the effective force constant of two springs with the same unstretched length but different force constants K1 and K2 are attached to a block with a mass m on a level frictionless surface. Calculate the effective force constant K sub EF in each of the three cases A, B, and C depicted in the figure. The effective force constant is defined by the summation of the force equal to negative K multiplied by X. An object with a mass of m suspended from a uniform spring with a force constant K vibrates with frequency F. When the spring is cut in half and the same object is suspended from one of the halves, the frequency is F2. What is the ratio of F1 over F2? Okay, so that's question 92, so let's look at this. So, for part A, the same force is developed by each spring, so it's the same F1 is equal to F2, so negative K1 times X, negative K2 times X, so the net force is going to be equal to F1 over F2, so the effective force constant is equal to K1 plus K2. So that's A. For B, so the restoring force of the two springs is going to be given by this F1 is equal to negative K sub 1 times X, and the same thing for F2. So then the force is equal to F1 plus F2, so the effective force constant is going to be K1 plus K2. It's pretty much the same thing as A. For C, the same force is developed in each spring, and so X1 is equal to X2, and so we have this equation here. The force is equal to K1 multiplied by K2 over K1 plus K2 multiplied by X, and so we get this equation K1 multiplied by K2 over K1 multiplied by K2. D, given that the force is equal to 1 over 2 pi multiplied by K over m. When the spring is cut in half, its mass becomes half, and so mass is going to be equal to m over 2. And so our frequency increases by the square root of 2.